Hey there, you landslide aficionado. You ready to dig into this fascinating topic? We're going way beyond just rocks tumbling down a hill today.
Definitely.
Your research collection is incredible. Academic papers, organizational profiles, the works. We've got prediction models, global initiatives, even some wild case studies.
Yeah, I was really impressed by the range of material you sent over.
Right. It really highlights how globally significant and complex landslides are. And our mission, if we choose to accept it, is to unearth the most valuable insights from all of this. Why should you care about landslides, you might ask? Well, buckle up, because this deep dive is about to take us around the world and below the surface, literally. To guide us, we have our expert who can synthesize scientific research faster than you can say mass wasting. So what's your take on the initial overview of the listener's research? What stuck out to you?
Well, what I found fascinating is that this research shows landslides aren't just a local problem.
Right.
They're a global phenomenon with, surprising connections. Take, for example, the paper comparing landslides in Japan and Sri Lanka. You wouldn't think those two countries would have much in common when it comes to landslides, would you?
Now that caught my eye too. Cherry blossoms and tea plantations. What's the common ground there?
It's all about the terrain. Both countries have similar mountainous landscapes, and they experience heavy rainfall patterns.
Ah, okay.
It's like this paper is revealing these hidden connections, showing how a risk in one part of the world can mirror a risk thousands of miles away. But it goes beyond just geography. It digs into how socioeconomic factors, like land use, play a role.
Location, 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 as they say. Which brings me to this paper. Interpretation and mapping for the prediction of sites at risk of landslide disasters. From aerial photography to detection by DTMs. This is an ICL landslide lesson from the book Progress in Landslide Research and Technology, Volume 3, Issue 1. It dives into using terrain analysis for predicting landslide risks. Now, this is where I need your help because deciphering the landscape secrets sounds a lot like reading ancient scrolls to me.
Well, imagine back in the day we relied on aerial photography to study landscapes. It was revolutionary. But today we've gone from those grainy photos to, high-resolution satellite imagery and even 3D microtopographic maps.
Wow.
These maps are so detailed, they show every nook and cranny. But the real breakthrough is what these maps reveal. They help experts identify areas prone to landslides by analyzing subtle topographic clues.
Okay.
It's like reading the history of the land, seeing how it shifted and moved over time. By studying past landslides, we can anticipate where future ones might occur.
So we're getting good at spotting risks on land, but this paper, global warming may accelerate submarine landslides in the oceans. Well, made a splash, so to speak. What exactly is happening under the surface that we need to know about?
This is where things get really interesting and a bit alarming.
Okay.
Climate change is warming our oceans.
Right.
And this rising temperature can trigger a chain reaction. Those underwater slopes, already under immense pressure, become destabilized.
Okay.
Warmer water essentially weakens them, potentially triggering submarine landslides.
Underwater landslides, what does that even look like? And more importantly, what kind of impact does that have?
Imagine a massive underwater landslide displacing huge amounts of water. That force can generate tsunamis, those giant waves that travel across entire oceans, causing immense damage when they hit coastal areas. This means even if you don't live near a coast, climate change is increasing the risk of tsunamis globally.
Okay, that's definitely something to consider. Now, shifting gears a bit to a more, shall we say, grounded topic, landfills. I never thought I'd be fascinated by garbage. But this case study on the Doña Juana landfill in Bogota, Colombia, completely changed my perspective. I have to ask, how do landfills and landslides even relate?
You're right to be curious. Landfills aren't just passive piles of garbage, they're dynamic systems. As waste breaks down, it produces leachate, a liquid, and gases. These build up pressure within the landfill.
Oh.
And just like too much pressure can make a balloon burst, it can trigger catastrophic landslides in landfills. What's fascinating is how this study emphasizes the importance of monitoring pore pressure ratios and the role of forced pumping in mitigating those risks.
That's not a mental picture I needed today. So landfills are a risk. What about solutions? We have research here about early warning systems, frameworks like the Sendai Framework Voluntary Commitments, and a Kyoto Landslide Commitment 2020. It seems like there's a global effort to tackle this, right?
Absolutely. We're getting much better at recognizing the risks and taking steps to prevent them. These frameworks show a real dedication to international collaboration. The goal is to share knowledge, develop early warning systems, and ultimately, save lives. But it's not just about high-tech solutions, it's about empowering communities too.
So it's not just about scientists and labs then. Where do we, the everyday folks, fit into this global effort to tackle landslide risks?
You sent a study about introducing Japanese landslide warning systems in Sri Lanka, and it focuses on the social aspect.
Okay.
That's critical. Early warnings are useless if people don't know how to respond. It's about making sure the information reaches those who need it most, and it's presented in a way that's understandable and actionable. Think accessible evacuation information and community training programs. These are all vital components of effective landslide risk reduction. It's all about bridging that gap between scientific understanding and what happens on the ground in communities. And your research digs into some very specific case studies that show the real-world impacts of landslides.
Exactly. It's not just theory, right? These are events that have a real impact on people's lives. It makes you realize how crucial this research is. For example, there's a fascinating study about the 2018 Hokkaido Eastern Iburi earthquake in Japan. I remember hearing about that. Thousands of landslides were triggered by that earthquake.
And your research delves into why. It examines the geological factors that made that region so susceptible to landslides. It's a stark reminder that it's not always rain that triggers these events. Seismic activity plays a huge role as well. We often think of earthquakes and landslides as separate events, but they can be intertwined in devastating ways.
It's like the Earth itself can be unpredictable, reminding us that we need to be prepared for a range of scenarios. This other case study from Nicaragua really drove that point home for me. It talks about how historical records, going back centuries, can help us understand patterns and predict future landslide risks.
That's a key point. Historical data is like a treasure trove of information. That study emphasizes how crucial it is to collect and analyze data from past events, even if it's not, traditional scientific data. Think newspaper articles, eyewitness accounts, anything that helps us piece together the history of landslides in a region.
So it's like connecting the dots between those historical records, modern science, and what communities know. It's fascinating how this research highlights that interdisciplinary approach. We're seeing geology, geomorphology, hydrology, even social sciences all playing a role. And it seems like technology is also key. From those early aerial photographs to techniques like LiDAR and INSAR, it feels like we're getting much better at actually mapping and monitoring landslides in real time.
Technology is definitely a game changer. LiDAR, for example, allows us to create these amazingly detailed 3D maps of terrain. We can pinpoint areas at risk with incredible accuracy. Then there's INSAR, which uses radar data from satellites to detect even tiny ground movements. That's what gives us that early warning potential.
Those are powerful tools, but technology is only as good as the people using it, right?
That's why the research on training and capacity building is so important. We need experts who can interpret the data, understand the science behind it, and then communicate those risks to communities in a way they can understand and act on.
It sounds like a lot of responsibility.
It's a shared responsibility. Scientists and engineers develop innovative solutions, policymakers set regulations and early warning systems, and communities learn how to be prepared. Everyone has a role to play.
It's a global effort, each player contributing their expertise. But beyond the technical stuff, there's the human element to consider as well, right? These landslides impact people's lives directly. Their homes, their livelihoods. It's heartbreaking.
You've hit on a crucial point. Landslides aren't just, abstract geological events. They can cause incredible suffering and displacement. The human cost is often overlooked, but it's at the heart of why we need to understand and mitigate this risk.
I'm thinking of the case study about the 2017 Athwal landslide in Sri Lanka. It resulted in tragic casualties and significant damage.
It's a stark reminder of what's at stake.
Mhm.
Your research delves into the factors that led to that event, from the region's geological structure to the heavy rainfall. But it also stresses the importance of community preparedness and response.
It's about building resilience, not just physical infrastructure, but also social support systems and a culture of awareness.
Exactly. We need to empower communities to be active participants in landslide risk reduction. That means giving them the knowledge, tools, and resources they need to make informed decisions and protect themselves.
So it's not just about building stronger slopes. It's about building stronger communities.
Well said. And that brings us to another compelling aspect of your research, the focus on communication. It's not enough to have the scientific knowledge. We need to share it effectively.
The paper on landslide risk communication caught my eye. It talks about using visuals, storytelling, even interactive tools to engage people and make information more accessible.
It's about moving away from dry technical reports toward engaging narratives that resonate with people on an emotional level. We need to make landslide risk relatable, understandable, and something people can act on.
We need to empower people to move beyond fear and into informed action. Speaking of action, what about the Sendai Framework voluntary commitments? How do those fit into all of this?
Those commitments are a powerful mechanism for global collaboration. Think of them as pledges made by various stakeholders, governments, organizations, individuals to contribute to the goals of the Sendai Framework for Disaster Risk Reduction. This framework, adopted in 2015, aims to significantly reduce disaster risk and losses by 2030.
So it's a global call to action with everyone doing their part.
Exactly. And many of these commitments address landslide risk specifically. They cover a wide range of activities, developing early warning systems, empowering communities, conducting research, sharing best practices.
It's impressive to see this kind of global mobilization, but how do these large-scale initiatives translate into real action on the ground?
They provide a framework for collaboration, knowledge sharing, and capacity building. For instance, they encourage the development of new technologies, like the Landslide Tracker app, which lets people report landslides in real time. It's citizen science in action, making people feel like they're part of the solution.
That's brilliant. It combines scientific expertise with on-the-ground observations. What other tangible actions are being taken?
Another example is the creation of regional landslide hazard maps. These maps use data from various sources to identify areas prone to landslides, which informs land use planning and infrastructure development.
It's about making smart decisions that minimize risk.
Precisely. And this risk-informed approach extends to engineering. Your research includes a paper about the challenges of building infrastructure in landslide-prone areas, highlighting new design techniques and stabilization measures.
Adapting our building practices to the terrain. That makes sense.
We're moving from reacting to landslides after they happen to anticipating and mitigating the risks beforehand.
It seems like a huge task, given the scale of the challenge.
It's not easy, but the progress made in recent decades is encouraging. New technologies are being developed, our understanding of the science is growing, and we're building stronger partnerships to tackle this global threat.
It's a journey of discovery, innovation, and collaboration. But it's not just about preventing disasters. It's about creating a more sustainable future.
You've hit on a crucial point. Landslide risk reduction is fundamentally linked to sustainable development. Protecting ecosystems, promoting responsible land use practices, and building resilient infrastructure. We're not just mitigating risks, we're creating a safer and more livable world for everyone.
It's a holistic approach, recognizing how interconnected natural systems and human well-being are.
And it's a journey we're all on together.
Speaking of journeys, we've covered a lot of ground in this deep dive, but before we wrap up, I want to touch on something that's been at the back of my mind.
I'm intrigued. What's on your mind?
It's the ethical aspect of all of this. Landslide risk isn't evenly distributed. Often, the most vulnerable communities, those living in poverty in remote areas or with limited access to information, are disproportionately affected.
You've raised an incredibly important point. Equity and justice are central to this issue. We can't just focus on technical solutions. We have to address the social and economic factors that worsen landslide risk for certain communities.
It's about ensuring everyone has access to the knowledge, resources, and support they need to protect themselves.
Absolutely. We need to prioritize inclusivity in research, policymaking, and communication. That means listening to the people most affected, understanding their specific needs, and working together to create solutions that are equitable and just.
It's a call for a more just and resilient future, where everyone has the opportunity to thrive no matter where they live or their socioeconomic status.
A future where we're not just mitigating risk, but also building a world where everyone has the chance to flourish.
That's a powerful vision.
Yeah.
It reminds me that landslide risk reduction isn't just about science and technology. It's also about values, ethics, and creating a more just and sustainable world for all. It's amazing how this research goes from global frameworks to the tiniest details. And you know me, I love those aha moments, those little nuggets of information that make you see the world differently.
Well, get ready for an aha moment about soil. One of your sources, a paper called Influence of Intraparticle Saturation Ratio on Strength Degradation of Pumice Soil, dives into how the internal structure of soil can actually impact landslide susceptibility.
Okay, confession time. Soil mechanics and I aren't exactly best friends. Can you break it down for those of us who don't speak fluent dirt?
It's like this. We often think of soil as, this uniform mass, but it's not. It's made up of individual particles with different shapes, sizes, and compositions. This paper focuses on pumice soil, commonly found in volcanic areas, and how its unique properties make it susceptible to landslides.
What is it about pumice soil that makes it so vulnerable?
Pumice is incredibly porous. Think of it like a sponge with tons of tiny air pockets. When those pockets fill with water, it compromises the strength of the soil. It's like weakening the glue that holds everything together. The paper explained how this saturation process, especially within the particles themselves, dramatically reduces the soil's strength.
So it's not just about how much water is in the soil overall, it's about where that water is within the soil structure itself.
Fascinating. Exactly. The research digs into the intraparticle saturation ratio. That measures how much water is trapped inside those tiny pumice particles, and the higher that ratio, the weaker the soil becomes. It's crucial for understanding how different soils react to water, leading to better predictions and prevention strategies.
So by knowing this, engineers can design better slope stabilization measures and create early warning systems tailored to specific soil conditions. It's like tailoring a soup, but for the earth itself.
Precisely. And while this study focused on pumice, the underlying principles are relevant to other porous soils too. It highlights how important it is to factor in soil mechanics when assessing landslide risks.
Another piece of the puzzle. We're seeing how everything is connected, from global climate change down to the tiniest particles of soil.
And your research collection doesn't stop there. It even takes us to the Grdelica Gorge in Serbia. That study uses a two-pronged approach to evaluate the risk of debris flows in that region.
Debris flows. Those are those terrifying, fast-moving mixtures of rock, soil, and water, right? What makes the Grdelica Gorge particularly susceptible?
It's about understanding where those flows might start. So the researchers first identify potential source areas. They look at topographic data, soil types, even historical records of landslides to pinpoint those vulnerable spots. It's like detective work, gathering all the clues to understand where the danger zones are.
Once they've identified the potential source areas, then what?
Then the real power of this approach kicks in. They use computer simulations to model how those debris flows might move. Slope, terrain, the debris itself, all of that is factored in to predict the path of a potential flow.
So they're basically creating virtual disaster scenarios, seeing how these events might unfold. That's incredible.
And incredibly useful for mitigation. By predicting those paths, we can identify vulnerable areas, infrastructure, communities, and take steps to protect them. But those models are only as good as the data they're based on. That's why this study emphasizes the importance of accurate data, ongoing monitoring, and integrating local knowledge, the people who know the land best.
Once again, it comes back to that interdisciplinary approach we keep seeing. Science, technology, community knowledge, all working together. But as important as the technical aspects are, we can't forget the human side of this, right?
Absolutely. This research constantly brings it back to communicating risk effectively, ensuring the information reaches the people who need it most, and involving communities in the decision-making process, empowering them to be active participants in their own safety.
Which leads perfectly to the paper on introducing Japanese landslide warning systems to Sri Lanka, focusing on the social aspects in the Arianic area. I found that one particularly insightful.
It showcases how crucial cultural context is in disaster risk reduction. You can't just transfer technology from one country to another and expect it to work the same way. The researchers went into the communities to understand their social norms, beliefs, and how they perceive and respond to risk.
So what did they find? How did the Sri Lankan communities view these warning systems?
They found that people were aware of landslide risks, but often lacked access to reliable information, especially about what to do if a warning was issued. It's a good system, if people know how to respond.
Right, a warning is useless if people don't know how to act.
That's why building trust between scientists, authorities, and communities is vital. This research highlighted the need for clear, concise, and culturally appropriate communication methods.
Working together, it really seems to be a recurring theme in all of this research. It's not just one solution or one expert. It takes a global network, doesn't it?
That's exactly what's highlighted in the information you shared about the Sendai Framework voluntary commitments. It shows a global community stepping up to address this challenge, acknowledging that it's bigger than any one organization or country.
It gives a much-needed sense of hope.
There's a whole network of researchers, practitioners, and communities out there dedicated to understanding, mitigating, and preventing these disasters.
This has been an incredible journey, hasn't it? We've covered so much ground, from the science behind landslides to the global efforts to mitigate the risks.
And unearthed some fascinating insights along the way.
But, like with any good deep dive, we've only scratched the surface. There's always more to discover, more to learn, and more we can do.
What's the main takeaway you hope our listener walks away with today?
Landslides are a complex challenge, no doubt. But they're not insurmountable. By understanding the science, using innovation, collaborating with each other, and empowering communities, we can create a future where everyone is safer and more resilient.
A future where we don't just exist alongside the forces of nature, but learn to live in harmony with them.
Perfectly said. And with that, we'll leave our listener with a question to ponder. In a world increasingly shaped by climate change and human activity, what role can each of us play in reducing landslide risk? Not just in our communities, but globally. It's something to think about. Thanks for joining us on this deep dive. Until next time.